Oh my god. Wow.
Wow, yeah, that's cool.
Okay.
Is this a figure 8 here?
Yeah, what are you guys? Are you figure 8?
Okay, now. Okay, now back together. Back apart. Together. Apart.
Bring them up here. Yeah. So you can see all these little plastic things here, and that is for that big piece of plastic right there. And that does the same thing as the plastic cover on that radar there. It protects all of these electronics and stuff. So the cool thing about this CPAR is called the cylindrical phased array radar.
That can allow the operating frequency all the way up to 40 gigahertz.
My name's Cody Pearsall, and I write the software that runs on the radars.
And I'm Blake McGuire, and I do general radar engineering duties. And as it gets bigger, it's broader and broader frequencies. So if you saw something like this that was designed for audio, like it needed to be perfectly quiet in here, then these would be much, much bigger on the side, and they wouldn't need to be as sharp here.
The Radar Innovations Lab was really interesting, just getting to see all of the different stuff that they can do with just like the LiDAR sensor, looking at that, the soundproof room that they made just using foam and paint. It was interesting to see how the radars actually worked, like the big radar trucks worked.
I liked how he depicted all different types of weather and what you have to go through to actually be a pilot.
We went to the flight simulator. They were talking about that if you can't see 3 miles away from the landing, then you have to like go around and go back again, or they can't do it.
Cloudy, it's misty, and the bases of the clouds are pretty low. So obviously we can't go flying today, which I know a lot of times if you ever see the helicopter take off, it's a pretty cool sight to see.
It just falls down. It's just like a seesaw. It goes back and forth until there's no more water filling up the bucket. There's a little magnet that hangs down, and every time it falls over, it passes the magnet by an electrical switch, and that tells the computer, oh, it rained, and it rained again, and again, and again.
We calibrated the rain gauges, and we tried to make it exactly 18.5 on the A and B side. In our group, it took about 10 tries to get to 18.5 on each side, and then we just kept testing it over and over.
But this represents 6.9 inches per hour of rainfall. So in other words, a ginormous toad strangler.